This question is from GATE 2017 Mechanical Engineering paper, set 2, question number 48. A product made in two factories P and Q is transported to two destinations R and S. The per unit cost of transportation in rupees from factories to destinations are as per the following matrix. Factory P produces 7 units and factory Q produces 9 units of the product. Each destination requires 8 units. If the northwest corner method provides the total transportation cost X in rupees, the optimized minimum total transportation cost is Y in rupees, then X minus Y in rupees is dash. So understand that first we need to find out the total transportation cost using northwest corner method, and then we need to find the optimized transportation cost using some other optimization method, and then we have to take the difference between those two costs. So let's find that out. So we'll start by drawing the table for northwest corner method first for finding out the total transportation cost, and for that we'll start with finding out the basic feasible solution. Now we'll draw a table to represent this transportation problem by writing the unit cost in the northwest corner. That is nothing but the northwest corner method. So factories P and Q, destinations R and S. Now P produces 7 units and Q produces 9 units. R require 8 units and S require 8 units. Therefore, let's check whether the problem is balanced or not. Production is of 16 units and requirement is of 8 plus 8, 16 units. So this is a balanced problem. Now let's do the allocation and find out the total transportation cost. So when P is producing 7 units, we will have to completely allocate all the units produced by P first. So we allocate 7 units that are produced by P to R. Requirement at R is of 8 units. Therefore, we'll have to use 1 unit from factory Q to meet this demand of 8. Then let's go for the destination S. Again, destination S requires 8 units. There is no unit left from factory P. Therefore, here it will be 0 or nil. All the demand that is required by S, that is of 8 units, will have to be met by factory Q, which is 8 units. So we can see that the number of units in each of the boxes is balanced here. Total units produced by Q, 9, are both utilized, and total units produced at P, that is 7, are also utilized. So this is the allocation. We can find out the transportation cost X. So transportation cost X will be 7 units into 10 rupees per unit plus 3 units into 1 unit into 3 rupees per unit plus 8 units into 4 rupees per unit. Plus this will be 7 into 0, 0. So this turns out to be 70 plus 373 plus 32, which is 105 rupees. Now this total transportation cost we have found out using northwest corner method, being the basic feasible solution. Now we need to get the optimum solution. This was part 1 to get the basic feasible solution. Now in part 2 we have to get the optimum cost. In order to get the optimum cost, we can use any one of the methods, and we will use this basic feasible solution for starter. So the non-degenerate basic feasible solution that we found out here, will start with this and make allocations for the unallocated positions, because these unallocated positions are going to decide what will be the optimum cost, because we have to reduce the cost now. Now if I make 1 unit allocation for destination S from factory P, I will have to balance all other units. So this will become 6. 6 plus 1, the demand will be met, which will be 7. All the units from factory P will be utilized, which is 7. Now for Q, in factory R we require total 8 units, so this will become 2. And for S also we require total 8 units, so this will become 7. So we have these allocations 6, 1, 7 and 2. But this is just the first step. We need to find out the optimum cost. By doing this, we see that the net change in the cost will be 1 unit we have added here. So this is 7. 7 is the addition in the cost. We have subtracted 1 unit from here. So minus 4. Again, we have added 1 unit here. From this 1 we have made it 2. So this will be plus 3. And again and for this box we have subtracted 1 unit. So this will be minus 10. So the cost will be totally reduced by 7 minus 4, 3. 3 plus 3, 6 minus 10. Minus 4. So change in the cost is minus 4, That means the new cost now is 101 rupees. But this is not the optimum cost. Remember, this is not the optimum cost. We are not finished allocating units. So to get the optimum cost, we will put as much as we can in this non-allocated position. So now we have only put 1 unit, but the maximum that we can put here is nothing but the total units factory P can produce. So factory P can produce 7 units. We will allocate all 7 units to this non-allocated position. So for the step 2, I will use blue color. I'm allocating all the 7 units to this non-allocated position, which are being produced by factory P. So this automatically will become 0 because there are no units left for destination R. Similarly, from factory Q, we have 9 units. Now, for destination S, 7 units are being met by factory P. The unit that we want to get from factory Q will only be 1 unit because demand at destination S is of 8 units. So, total demand at S will be met, while total demand at R will be met by factory Q alone. All the 8 units should be allocated by factory Q. Now, we can find out the optimum cost. So, the optimum cost Y will be equal to this allocations that I have made in blue are my final allocations. So 7 into 7 plus 1 into 4 plus 8 into 3. Total cost will be 7 sevens are 49 plus 4, 53 plus 24. That is 77 rupees. So this is the optimum cost Y. Let me summarize. What we did is, first we found out the total cost using northwest corner method, which is our basic feasible solution. Then we have used the basic feasible solution and made allocations for the non-allocated position. We need to make maximum allocations to the non-allocated position so as to get the maximum gain. And this will give us our optimum cost of transportation, which is Y. Now, simply we need to find out the difference between the two. So X minus Y, which is being asked, is nothing but 105 minus 77. So we see that the answer we got, 28, is not given in the options because this question has a fault in it. And in that year, marks to all were given for this question. So actually our answer is 28. All the options are wrong here. Answer is 28. To learn about transportation problems in detail, you can refer to the NPTEL video, Lecture 13, Transportation Problems, and Lecture 14, Transportation Problem Optimal Solutions. These videos are from the course Lecture Series on Fundamentals of Operation Research. The course is by Professor G. Srinivasan. He is from Department of Management Studies of IIT Madras. I hope this solution will help you clear your doubt. Thank you.